In this film, we're going to repeat some information we learned in the production theory part, and we're going to evolve that one into finding the demand function for production factor. So we start with the short run production function where we have the total production on the vertical axis and the labor as we're using as the production factor we're interested in now to find the demand function for on the horizontal axis. We know that on the short run we have a relationship here. The quantity of the good that we're producing is a function with the variable factor labor and the fixed factor capital. And in this case the capital is fixed to K1 units of capital. And we see that we have a symbolization here that gives us diminishing margin return. So in the beginning here we have a steeper and steeper slope, and eventually the slope is still positive but it's not as steep as possible, and then we reach the top, and after that the slope is negative. And that is something we're going to use when we look at the modular product, the production per the last employed unit, or per 1 unit or something like that. It's the definition mathematically, it's the change in total production when we change the usage of labor units. What we're interested in is the maximum value. So we're looking for the steepest slope we have on the total production function, and we'll find it there. So up to that position, the slope becomes steeper and steeper, and after that the slope becomes more and more flat. So this one will give us the highest production that we're going to get from 1 unit of labor, 1 additional unit of labor. When we look at the top of the total production function, we see that this one has a slope equal to 0, and since the slope is giving us the marginal product, the marginal product has to be equal to 0 as well. So this unit doesn't contribute positively or negatively to the total production. It contributes with 0. But we know that the next unit will have a negative contribution. It will make the total production go down. So if we move that one downwards into a new graph where we have production per unit of labor on the vertical axis, so it's a different scale than we had on the upper graph, the upper figure there. But we still have the same horizontal axis. So then we know that the modular product will increase up to its maximum, and the maximum will be at LPM L max, and then that has to decrease, and we know that it's going to have a value of 0 for this unit of labor. So therefore we can draw this graph schematically looking like this. The same thing we can do with the average product. The average product is the production per labor on average. So we take all the labor units we have and we calculate how much units they are producing. So therefore we can take the total production divided by the number of labor units to get an average. That could be found by draw a straight line that goes from origin and upwards, and the steeper this one is, the higher will the average be, because we have more and more on the vertical axis compared to the horizontal axis. And the highest, steepest version we can find from this beam that goes from origin is the one where we just have a tangency. And that also gives us a clue that since it's a tangent, it has to be equal to the slope, and the slope was given to us by the modular product. So therefore we know that this has to be equal to the modular product as well. But let's show that this is actually true. We know that this unit of labor, this quantity of labors, have given us the highest possible average product. So therefore the average product has to be increasing up to this position, and from that position has to decrease. So this one will give us the maximum point for the average product function. We also know that there is a relationship in mathematics that we can't do anything about, and if we can't do anything about it, then let's use it. And that relationship is that to get an average to increase, you have to add an additional value that is higher than the previous average. And to get an average to decrease, you have to add a marginal value that is less than the average. And in this case, we know that the average product has its maximum somewhere along this line. We also know that it has to be equal to the modular product, which we saw up here. So therefore, it indicates that the average product will be intersected by the average modular product curve at maximum point there. And we also see that the relationship we had in the mathematical world, in this scenario, in this area here, we have a module that is higher than the average, and the average is increasing. And in this area, we have a module that is less than the average, and the average is decreasing. So let's just look at that last graph, and we're going to evolve that a little bit because we are paying the labor not in the production they are making, but we are paying them money. So let's see what happens when we make a monetary valuation of this. We have the modular product, we had the average product, so they were increasing to their maximum and then they were decreasing. And to be able to find the monetary value, we have to calculate the value that this brings to the company. So to do that, we have to introduce a new vertical axis with monetary valuation, in this case euros. So to be able to find the monetary value for the company, we need to calculate what is called the marginal revenue product. We've got the modular product, that is the production for the last employed unit of labor. That production is sold on the market, the Q market, and brings a certain marginal revenue. So therefore, the value of the last labor unit is the production it makes times the marginal revenue that production brings. So the maximum of the modular product has to be equal at the maximum for the modular revenue product up there. And we also know that 0 times something always becomes 0, so therefore they have to be intersecting the horizontal axis at the same position as the modular product does. We can do the same calculations but on the average value, and therefore we got an average revenue product, which is the modular revenue for the production that we are doing on average. And that one will of course be similar to the one that we had. So the maximum value for the average revenue product will be at the same maximum quantity of labor as the average product. And it has to be intersected by its modular value. In this case, the modular revenue product. So if we're using that one and we go directly to the part that we're interested in, the monetary valuation here, and we try to find the demand function, then we have the modular revenue product, goes up to its maximum and then goes down. We have the average revenue product, goes up to its maximum and then declines or decreases, and it is intersected by the modular revenue product at the maximum point. So let's assume that the company that we're looking at is a price-taking company on the labor market. It could be that they are actually working on some kind of a perfect competition market, but it could also be that they are involved in signing contracts with the labor, so that they know that the price, the wage rate that they're having. So let's start analyze this one. We have a rather high wage rate at the beginning, so WA is a high wage rate, and that will give us that the marginal factor cost, the cost of buying one additional unit of labor, will be the same. It will always be WA. So if we look at one of the units here, let's take this one for instance, then we see that this labor unit brings a value to the company that is equal to the marginal revenue for that unit down there. and the company has to pay the wage rate WA for that one. So we see that the revenue that we will receive is much lesser than the cost I have to pay. So this is of course something that is uninteresting for the company. So that one will not be interesting to buy if they doesn't have to buy them. So therefore we see that this unit up here, that one will give us marginal revenue that is equal to its marginal cost. So that one will bring 0 change in the profit. It will cost you the same as you have in revenues. And the individuals between here will have a marginal revenue that's higher than the cost that the company has to pay. So that one will bring a positive. So that indicates that out of all the units that we're interested in, this one could be the one that we were willing to buy. And that is based on the same fact as we always have. It's the marginal, it's type of profit maximizing scenario, the marginal revenue equal to its marginal cost. But let's see what this actually brings to the company. So we know that if they are facing WA, they could be willing to buy LA units of labor. But what's the profit for the company if we do this? Well, we start by calculating the total variable cost. The total variable cost is, as usual, the wage rate times the labor units. So in this case, WA times LA, which is this big rectangular there. That's the total variable cost. And remember, we also had fixed cost. We had using K1 units of capital as well. So we both have fixed and variable costs. So now we should try to calculate the total revenues that the company will have. And to do that, we're going to use this average revenue product curve that we derived here. So when we multiply the average revenue product with a certain number of labor, then we can rewrite this one. So make the simplicity that we are selling in a perfect competition market. So the marginal revenue is equal to the price of Q, the market price Q, times the average product, times L, which we got there. So this is the definition for the average revenue product, and then we multiply that with the labor units that we are buying. So therefore we get L times PQ times Q divided by L, because this is the average product. And if we look at it, we see that we got L times something divided by L, so those two L cancels out. So what we're left with is the PQ times Q, which we know is the total revenues for the company. So when we look at this, we see that the total revenues, if they are buying LA units of labor, they will have a total variable cost that is greater than its total revenues. So we don't even cover our variable costs, and then we also have to pay for the fixed cost. So this is something that is not interesting for the company. It will not be a part of the demand function. So let's see what happened. If we look at another wage rate, like take wage rate WC, we're using the profit maximizing solution scenario, marginal factor cost equal to marginal revenue product, and realize that we are willing to buy LC units according to the marginal condition. And we calculate the revenues, so we have to go up to the average revenue product for LC, and we realize now that the total revenues is this great rectangular, that green dot times LC, like that. And the total variable cost we got here is WC times LC, and that's this rectangular. So we see that we got a rectangular here which is giving us a positive difference between total revenues and total variable cost, which we can use to pay for the fixed cost, and perhaps even covering some positive profits for us. So this is definitely something that we're interested in buying. So let's see, what's the highest wage rate this company in this scenario is willing to pay? Well, it's quite easy to see that it has to be wage rate WB. Because if we are facing a wage rate of WB, we have that the total variable cost, WB times LB, will be equal to the total revenue, which is LB times the average revenue product at LB. So those will be identically large. So therefore, for this company in this scenario, if they are facing WB, that they will have a loss, a total loss of its fixed costs. And that is, of course, something that we have looked upon when we looked on the supply function for a price-taking company. They were interested in starting selling as soon as they were covering all the average variable costs, or total variable cost. So the supply function started at average variable costs minimum. And that indicates then that, of course, that this will give us that the demand function for, in this case, a labor, will be given by the marginal revenue product and from the intersection with the average revenue product and downwards. And since we're anticipating that we can't, it's not normal to have negative salaries or wage rates, it will stop at the horizontal axis.